a firm, a human resources department has a budget of 25,000 to spend on training and laptops. So training courses cost $700 per employee on average, and a new laptop costs $1,200. Okay, so now if the department trains E employees and buys L laptops. Now write down the inequality for E and L. So write down the budget inequality for E and L. So we have the budget of $25,000 over here, and this is the maximum amount that you can spend. Okay, this is the maximum amount that you can spend. This is the maximum amount that you can spend. So this is should be a less than or equal sign. Okay, you can spend at max at $25,000. Okay, now what is the total amount spent on employee training? So on average, on training costs $700 per employee. So that means the total cost spent on training should be 700 multiplied by E. E is the number of employees. Okay, and what is the total costs for buying laptops? So each laptop costs $1,200. So that means 1,200 plus 1,200 multiplied by L, the number of laptops. Okay, so I repeat again, 700 E is the total cost spent on training. Okay, 1,200 L. Here is the total cost spent on buying laptops. Okay, so you add these two up, and this has to be at max $25,000. This is our inequality. Okay, this is a budget constraint, or what we call the budget constraint in this case. So now B, if 12 employees in 10 courses, and so how many laptops could be bought? So in this case, we always have this inequality, but now there's 12 employees registered for the course, so we only have E. Here is 12. Okay, 12 employees. Now we saw for L. Okay, so perform a very simple problem solving thing, and you can arrive at the solutions, which is 13.83. Okay, so but do not stop there. Okay, they said how many laptops could be bought. How many laptops could be bought? You cannot go to the stores and say that, hey, I want to buy 13.83 laptops. Okay? Cannot say that. You cannot go to the store and say, hey, I want to buy 13.83 laptop. The last laptop, please do not include the keyboard, the screen, and anything. Yeah? Just give me the laptop without a screen, without a keyboard. That's not possible. So do not forget your conclusion. So how many laptops can you buy? Okay, exactly how many laptops can we buy? Okay, can you buy 14 laptops? Can you buy 14 laptops? So in this case, we should do we round up or round down? Okay, round up or round down. So can you buy 14 laptops? Okay, let's see. If you want to buy 15 laptops, you get our inequality. Now we have 700 multiplied by 12 plus $1,200 multiplied by 14. For example, if you want to buy 14 laptops, okay, and that will equal, that equals 45,200, right? 25,200. So this number already exceeds the budget over here. Okay, 25,200. This number already exceeds the budget over here. Okay, so 14 laptop is not possible. So in this case, we have to round down. So that means so you can only buy 13 laptops. Okay, so do not forget your conclusion. Okay, do not forget your conclusion. Answer the questions. Okay, any questions? Any question concerning this case? Oh, good. Everyone's good. Okay. Again, let's move on to the next topic. So function, what is a function? So for example, we have function of fx equals y equals x plus 1. So a function f here, it tells us what we need to do with x in order to generate the y. Okay, so f is the form of the function. What we need to do with the x, in this case, to get the y. And what about here, x in the brackets here? It tells you what is the variable put in the function. For example, in this case, the variable put in the function is x. Okay, this would change if you put z in this case. So this will become z. If you put a in this case, your variable here should be a. Okay, so f is the function form. X is the independent variable put in the function. So what I just said, what is independent variable? Okay, so if we write down y equals x plus 1 in this case, if we write like so, y equals x plus 1. So that means you can freely choose what the value of x to put into the functions. Okay, you can freely choose the value of x and then put that value of x in the function. So that's why x in this case is what we call independent variable. Okay, so after we pick a random value of x of your choice and put in the function over here. Okay, so now we can calculate y. Okay, so y is what we call dependent variable. Okay, why? Because it depends on the value of x according to this description. So you can freely pick the value of x. So that's why we call x in this case independent variable. And after picking the value of x, you perform mathematical calculations and arrive at the y value. So y here depends on the value of x. So we call it dependent variable. Questions? Any questions? And no one. Let's continue. So, how do we linear equations? Okay. So, what is linear equations? Basically, is the equation to a line. Okay, linear, tính tính. Okay. Or equation of the line. So a line has a equation of function of a line has a form of y equals ax plus b. Okay, so a here is what we call coefficient. Okay, r it represents the slope of the line. Okay, it also represents the value of change in the value of y when x changes 1 unit. So if x changes 1 unit, how much y will change that depends on the a over here. Okay, and a and b are both called parameters. Okay, a and b are both called parameters in this case. So repeat again, a is what we call it coefficients or slope of the line. Okay, and a and b here in this case we call parameters. And of course, x is the independent variable and y is dependent variable. Okay, some of the vocabularies here for you. For example, we have the this axis here we call the y-axis or the vertical axis. Okay, and the line here, the axis here, we call the x-axis or the horizontal axis. Okay, and here we call the origin. What is where the x-axis crosses the y-axis? We call the origin. Okay, so where the function crosses the y-axis, we call is y-intercept. Where the function of the line crosses the x-axis, we call is x-intercept. Okay, any questions? So with that, let's move on to supply and demand analysis. So what is demand function? So demand function is just a mathematical way to describe the behavior of consumers or buyers. Okay, I believe you already learned this in your microeconomics class, but I'm gonna review some of the knowledge here. So I repeat again, demand function is the mathematical way to describe the relationship between behavior of consumers or buyers. Okay, what are behaviors of consumers? So when price rises, they will buy less. Okay, if price drops, they will buy more. Okay, so Q here is the quantity the consumer wants to buy. P here is the price. So we have assuming the relationship between Q and P here is linear. That is a line. Okay, a line. We have Q equals AP plus B. Okay, so like what we said, with consumers, if price rises, Q will drop. Okay, if price rises, people will buy less. If price lowers, people will buy more. So that means there are negative relationships between P and Q with the demand function. So that means the A here has to be negative. Okay, the A here has to be negative. Okay, so that when P rises, if A is negative, Q will have to drop. So in order to have the negative relationship between P and Q, A here has to be a negative number. This is what we call a decreasing function. Okay. So to demonstrate here, we have a downward sloping line over here. Okay, to demonstrate a decreasing function, or a here, or the slope of the line here is negative. Okay, similarly for supply function. So supply function describes the behaviors of sellers or manufacturers. Okay, what is the behavior of sellers? When price rises, they would tend to produce more, okay, in order to captivate more profits. Okay? If price lowers, they would tend to produce less, okay, and reserve their resources to other things that that can bring in more profits. Okay. So with suppliers, the short price rises, produce more, and if price drops, produce less. Okay. So there's a positive relationship between P and Q. Okay. That means this is a increasing function. Okay, represented by a upward sloping line. Okay, so the function here Q equals AP plus B. A has to be positive to show that there's a positive relationship between Q and P in this case. Okay, any questions? Any questions so far? Are you all good? Okay. So no questions. Okay, let's move on. So there has to be a point where quantity supply exactly matches the quantity demand. At this point, is what we call an equilibrium point. So the quantity that consumer wants to buy exactly equals the quantity that suppliers want to sell. I repeat, the equilibrium point is the point where the quantity that consumers want to buy exactly equals the quantity that sellers want to sell. Okay? So that point is what we call the equilibrium point. Okay? So graphically, the equilibrium point is the point of intersection between the supply and demand curve. Graphically, the equilibrium point is just a point of intersection between supply and demand. So, mathematically, how do we solve for that equilibrium point? We solve the equilibrium point by solving the simultaneous linear equations. Okay? Okay? By solving simultaneous linear equations by the first function is the demand function, the second function is the supply function, or vice versa. So put the supply and demand function over here in the simultaneous linear equations and then solve for the solutions is the equilibrium points. You can solve this by using your calculators, okay, or using elimination method that you learn in your high school, or you can use graphical method that is drawing the line in a very accurate way, so that you can determine the point in the graph, which is the equilibrium point. Okay. Last thing. Actually, it's endogenous variable versus exogenous variables. Okay, so this thing you will see again in some classes, but will be mostly used when you work on your thesis. So So back to our demand functions. We have our demand function Q plus AB plus B. Okay. Uh, so in this case, Q and P are variables that are shown in the model or in the equations. Okay. So if the variables that are shown in the equations, they are called endogenous variables or in the model. Endogenous variables or variables in the model. Okay. Okay. Now, thing is, if we write it like so, we that is because our main interest is exploring the relationship between price and quantity. Okay, if that is our main interest. It's only exploring the relationship between Q and P, but the quantity the consumers want to buy does not solely depend on the price only. Okay, although it largely depends on the price, that is not the only factor that affects the quantity that consumers want to buy. So that leads us to there could be other variables that affects the quantity of consumers want to buy. For example, we have income. Okay. For example, if you are rich, chances are you would want to buy more. Okay. For example, price of substitutable goods or price of complementary goods, and we will touch on later on. So if there's other alternatives that have the same function, okay, but the price is lower, of course you would want to go to the alternative, leaving the quantity of the goods that you want to buy lower. Okay, so that could affect the quantity consumers want to buy. Okay, and other things could be advertising expenditures. Okay, for example, if sellers pays a lot for advertising, chances are consumers will buy more of that products. Okay, and vice versa. If one will spend that advertising, chances are quantity that consumer want to buy will be less. Okay, other things is consumer taste. For example, consumers would not want to eat ice cream during cold weather. Okay, so during cold weather, the quantity of ice cream is less. Okay, it's lower compared to hot weather. So that consumers taste. So these factors: income, price of substitutable goods, price of complementary goods, advertising, consumer taste. These factors do not appear in our original model. Okay, if they do not appear in the original model, okay, that means we have implicitly assumed that these factors remain constant. Okay, so these factors that are not in our models, they are called exogenous variables or out of models variables. Okay, and they are assumed to hold constant in the demand function over here. We will assume these will be a constant number and they do not vary. Okay, we only allow P and Q to be varied, not these types of variables. So what we call these are exogenous variables, and they are assumed to be constant. Okay, if they are assumed to be constant, you have constant plus constant plus constant plus constant. So these have to be resulted in some number, right? They have to result in some number. That some number, K, is the B here. Okay, that certain number is the B here. So you add all these constants up and you get the B over here. Okay, so that's why if there's changes in exogenous variable, there would be changes in the B over here. Okay, if there's a change in the B over here, your line will, well, your line will move, right, parallel with the original line. Like you always learned in your high school, when the B here changes, your line will move parallel to the original line. Okay, any questions for this part? Do I make myself clear? Others is any unclear things? Okay. I hope I don't scare you away. Now, so this last problem is probably the most important one in the chapter. Okay. So in this chapter, we only have, I think this one is the most difficult. So let's go over it. Now, we're given demand and supply functions of the good over here. So these two equations, and then we are asked to calculate the equilibrium price and quantity. So again, how do we calculate the equilibrium price and quantity? We solve the simultaneous equations that consist of the demand function and the supply function. Okay. So first of all, in equilibrium, like we already said, QD or quantity demand, or the amount that customers want to buy exactly equals to the amount that sellers want to sell, and this has to be equal to some Q. Okay, so Q the same, QD equals to QS, and P is the same, so we can rewrite this as A over here. That is equals and we solve for Q. Q equals what? Let's see. $21, and then you plug that in. Well, Q equals 21 to either of these equations, and you arrive at P. So P equals 36. Okay, you put Q back in one of the two equation over here, and we will arrive at P equals 36. So this is our equilibrium price and quantity. So remember, they asked for price and quantity. So you have to answer them with the solution of price and quantity. And do not leave anything. Do not stop at Q equals 31. Okay? You will lose points if you don't answer what is the price over here. Some points during exam. So that's the first one. How to refine the equilibrium price and quantity. Now, calculating equilibrium and quantity after imposing tax. Okay, so we're good here. So we have, this is our original equilibrium price and quantity. Now the government imposed a fixed tax of $13 per good. Okay, so for every good that is sold on the market, that would be a $13 tax. Okay, so in this case, it is unclear which side the government will put the tax on. The government could choose to tax the buyers, okay, or the government could choose to tax the sellers. Okay, in this case, the problem does not say anything about this, so you can freely assume which side the government could tax on. So first, I will assume tax on sellers first. Okay, so two side demand or supply, and in this case, I will choose to put tax on sellers. Let's see what happens. Okay, if this tax on sellers, what happens? Okay, if the government chooses to put tax on sellers, what will happen? They will change the behavior of the sellers. Okay, if the government put tax on the sellers, they will change the sellers' behavior. If they change the behavior of sellers, that means your supply function will change. Okay, because the supply function reflects the behaviors of the sellers. So if the sellers changes behavior, then your supply function has to change. So how the supply function change? How does the supply function change? So for example, I have goods that can be sold, that is sold for $100. Okay. For example, I have a goods that is sold for $100 in the market. Okay, that is after tax. I'm sorry, before tax. Sellers receive. So if, for example, I sell a good that priced at $100. Okay, so before tax, before any tax, right, I will receive the whole $100. Okay, because the government does not collect tax. If I sell a good for $100, I will receive $100. Okay, but after tax, what happens? After tax, I sell a good for $100, but now I have to pay for $13 in tax. Okay, I will pay $13 in tax. That means I only receive $87. But before tax, I sell stuff, I receive $100. After tax, I sell that stuff for $100 on the market, but I do not receive the whole thing because I have to give the government back $13. So that means I only receive $87. Okay. So this is a very specific example right? Very specific example. So to generalize, uh, before tax, I sell stuff and receive P. After tax, I sell stuff and only receive P minus 13. Okay? So before tax, I sell stuff and receive P. After tax, I sell all that's the same stuff, but only receive P minus 13. Okay, so that means we replace P with P minus 13 in the supply function. For example. Okay, so if that is the case, this is our new supply function. Replace P with P minus 13. This equals plus 42. So this is our new supply function. Note that this is it. Replace P with P minus 13. So this is just a simple problem. If there's a P over here, for example, and there's also a P over here, okay? For example, if there's a P over here and P over here, you have to do the thing and replace everywhere that has the P with P minus 13. So here is P here replaced by P minus 13. Over here we have P also that should be replaced by P minus 13. If there's a P here also, this should be replaced by P minus 13 also. Okay, so everywhere that P appears, you have to replace it with P minus 13. This is a more complicated scenario. Yeah, in this case, we only have P on the left side, no P on the right side. So here is our new supply function. So now we have new supply function, and since we said that we only reflect the supply function, okay, demand function remains the same over here. Okay, so tax on sellers, that means that only affect sellers' behavior and buyers' behavior does not change. This here affects supply function, so this is our default supply function, and the demand side remains the same or unchanged. So that means our new equilibrium So we can solve for a new equilibrium point by solving the systems. What is that system over here? Is the so we said demand remains the same, so we just copy over here. And then supply changes. So what is our new supply function? We already found it over here. So here. So because it's a equilibrium point, QT equals QS, so that's Q, and solve for this system, and you find that P equals, sorry, Q equals 13, and then P equals 48. Again, you can either put that in the calculation, or you can use elimination method. Okay, that is you have this sign minus this sign, and this, again, or for following. So if you use elimination method, it will be like this. It comes like this. Here, and then solve for Q. Okay, and then we find P. Okay, so this is our new equilibrium price and quantity. Okay. Any questions so far? Any questions? I hope you all doing well. Okay, so let's continue. Now, that is the first part of the question. So, who pays the tax? So who pays the tax? So remember that we had this here, before tax, equilibrium before tax, and we have equilibrium after tax. Okay. So in this scenario, this is tax on sales. So in this scenario, tax is placed on the sellers. However, look at the price. Before tax, consumers only has to pay $36 for that good. Now, after tax, consumers have to pay $48, even though officially tax does not place on consumers. Okay, officially tax is not placed on consumer, but the consumers has to pay for a higher price over here. Okay, so that means that differences is actually tax on consumers. Okay, even though officially consumers taxes placed on consumers, but they have to pay. But now consumers have to pay for a higher price. So that difference is the tax, actually tax placed on consumers. So that means consumers have to pay $12 in tax. Okay. Now, the consumers already paid $12 in tax. Okay, so that means sellers only have to pay $1 in tax only. So the total tax per good is $13. But now consumers already paid $12 in tax. So that means sellers only need to pay $1 in tax. Okay, that is 13 minus 12. Any questions over here? So essentially, when there's a tax, okay, sellers in this case push $12 of tax to the consumers. Okay, in this case, sellers push $12 tax to consumers, and they only have to pay $1 tax in this case. Okay. In most cases, sellers do not push all the tax to consumers because they are afraid that that will scare consumers away and that will they will receive less profits. So that's why in most cases, sellers do not push all the tax burden to consumers, but they have to push some tax burdens to consumers. Okay, how much tax burdens consumers have to share depends on how much desire consumers are related to that good. If the consumers really want that good, okay, that means that will enable sellers to push the majority of tax burden to consumers. Okay, and in other cases, if the consumers does not show that much desire on that good, okay, so that will only leave sellers a little choice, but to share most of the burden of the tax. If the seller has to share most of the tax burden, if the consumers do not want that good as much. So, but in this case, sellers could push the majority of tax burden to consumers. In this case, $12 tax applies to the consumer. Sellers have to only pay $1 tax. Okay. Any questions? Oh, good. Now, I have already demonstrated how you solve the problem if you assume the tax is placed on sellers. Now, what happens if you assume tax is placed on buyers? How do we solve the problem? So assume tax on buyers, so what happens? So we already said, so if tax is placed on buyers, that will affect buyers' behaviors. If buyer behavior is affected, that means it will change the demand function. And since tax is placed on buyers, that means suppliers on supply side remain the same. Okay. Now, on the buyer side, before tax, buyers has to pay. Buyers pay P plus $100. But after tax, buyers pay now they already paid $100 to sellers, but that is not done. Now, because tax is placed on buyers, now buyers have to pay additional $13 in order to receive that good. Okay? They have to pay $100 to the sellers, and they have to pay additional $13 to the government. Okay? So that means before tax, they buy the good at price P. After tax, they buy the good at price P plus 13. And this is, it would change the demand function. So replace P with P plus 13 in the demand function. Before tax, buyers pay price P. After tax, they pay P plus 13. Okay, so replace that in your demand function over here. So this is our new demand function. That replace p with p plus 13 in the demand function. Okay, demand function over here. So we have p equals plus 1 plus 1 7. Yeah. So this is our new demand function, and we say that our supply remains the same. So let's copy the supply over here. So supply side remains the same, and here is our new demand function. So plug it in over here, and since at new equilibrium, Pg has to be equal to Qs, only Q over here. So you can rewrite this as then, right? Check. Okay, so that is resolved at Q equals 18. Q still equals 18, and P now becomes 36. Okay, Q now P now become 36. So replace the tax in this case. Duplicate the signs. So replace the tax in this case. So tax on buyers. Now P equal. I'm sorry, this is 35. Sorry, 35. Is that correct? This is 35. This is 35. So before equivalent before tax, Q put 21 and P 36. After tax, you place the tax on buyers. Q equals 13 and P equals 35. Okay. Now this is tax on buyers. Okay. So officially, officially sellers, officially the buyers. The sellers do not pay for the tax. But this is the price difference between here and here. Before tax, they can sell the good for $36. Now after tax, they can only sell the goods for $35. So they have received $1 less. So that essentially is the tax on sellers. Okay, so before tax, they can sell it for 36. Now they can only sell it for 35. So that means 36 minus 35 is the tax placed on sellers. Okay. Now tax on buyers has to equal. It's because the total tax is 13, and then sellers already pay $1 in tax. So that means buyers has to pay $12 in tax. Okay. So take a look at these two scenarios. If you place tax on sellers, sellers have to pay $1 in tax, and consumers have to pay $12 in tax. If you put the tax on buyers, then the seller still pays $1 in tax, and buyers still pay $12 in tax. So from this, we can conclude that with fixed tax, yes, with fixed tax, for in this case, $13 per good. It does not matter which side that we wish to place the tax on. Okay, the buyers still have to pay 12 dollars in tax, and sellers still have to pay $1 in tax. So doesn't matter which side you put the tax on. Okay, the tax burden is shared the same in both cases. Okay, what factors that decide which sides have to share more tax burden is how much they desire for the goods. If they really desire that person has to share a lot of tax burden. Okay. So another thing that the government can conclude from this is that it doesn't matter which side I place the tax on. So of course I would choose the side to place tax so that it could be easily to collect. For example, we have a VAT tax, or the tax on goods sold. Okay, so in that case, there's a lot of buyers coming to the stores and buying goods. Okay, the government cannot keep track of how much each person buy this stuff, that stuff, other stuff. Okay, so what do? They will ask the sellers to make a tax report every month. Okay, in that they have to calculate how much the VAT tax, and they have to the sellers then have to pay that VAT tax for the seller. I'm sorry, for the buyers to the government. Okay, they have to pay the tax to the government. So in this case, the government will collect tax from buyers because this is more easy instead of keeping track of every customer out there. They only ask the sellers to make a report. Okay. Otherwise, I will not let you continue your business. Please make a report on how much tax, VAT tax, could be collected, okay, and then give that to the government. Okay. So that one case, how to decide how the government uses to make tax policies. Okay, any questions? Questions? All good? Still okay? 4? Okay, so last content. So last thing, transposition of formula. So let's just simply rewrite. So for example, we have P with respect to Q over here. Okay, we have P with respect to Q over here. Which we can transpose it to Q with respect to P over here. This process is called transposition. I believe that you all be familiar with this process, just learning new vocabulary over here. So this process of changing P with respect to Q with respect to P, what is called as transposition of one way. Okay, and that concludes our lesson today. If you have questions, please let me know. Otherwise, good evening. I will end the class here. Okay. Any questions? Okay. Do have a happy evening. I will see you face to face next week. Okay. And do remember to do the quiz on Wednesday. Okay. Okay. I will see you later.